Hello, Algebra 3 friends. So I have put together slides again for Lesson 5.2. I think the consensus was that Lesson 5.1 was pretty easy. So that was the recursive formulas. Those are the formulas that you use if you're going to find just one term after another term after another term. Today we're going to do the explicit formulas. And the explicit formulas, they allow you to find a term that's way out there, like the 23rd term or the 37th term. And so if you have a formula that lets you do that, it's a lot easier than trying to just write the sequence out until you get to that number. So that's the formulas that we're going to look at today. The lesson looks just a lot like the 5.1 one did, only I've switched it over to the 5.2. So here's the blank version of the notes if you want to print them out and go through them with me. There'll be a completed version posted right here after I get them done today. So I hope that you'll go through and watch the lesson and then work on the homework when you get done with that part. So here are the formulas. The top part of the notes has them and they're right here. I put them big so that you could refer back to this slide if you needed to with the formulas on it. Excuse me. I'm going to go over here to the ladybug. Okay, so this is the arithmetic sequence explicit formula. This is the geometric sequence explicit formula. And we already talked about what all these letters mean, but I'll go on them again. So this is a sub n, and that just means the value of the nth term. So if you're looking for the 12th term, it would be a sub 12. If you're looking for the 17th term, a sub 17. Equals a sub 1. A sub 1 is the value of the very first term, okay, the very first term. Plus d, that's the difference. So that's what it takes to get from one term to the next term to the next term. In arithmetic sequences, you're either going to add a number or subtract a number. So that's the d. And then in parentheses, you put n minus 1. So if you're looking for the 12th term, this would be a sub 12, and you'd put a 12 in right here, 12 minus 1. So we'll do some examples where we write this formula, and we'll do some examples where we use the formula to find a certain term. Geometric sequence explicit formula looks very similar, only it's an R instead of a D because we know it's a ratio or a rate that it takes us to get to the next term. So times 2 or times 1/2 or times 1/4. That's what geometric sequences do. We put that R in there, but otherwise everything means the same. It's a sub n. So if you're looking for the 22nd term, it'd be a sub 22 equals a sub 1 is the first term. R is the rate, so whatever the rate is that takes you to get from one term to another. And then the rate is raised to a power. It's raised to the n minus 1. So I gave the example a sub 22 if you're looking for the 22nd term. So you'd put a 22 in right here for 1. And that's how the formulas work. And now let's do some examples where we go through the formulas.